When installing a subpanel in a residential garage fed from the house, adhering to the National Electrical Code, or NEC, is essential for safety and compliance. The inspector requiring a 4-wire setup and a ground rod is following the NEC guidelines. Section 250.30 of the NEC mandates that a grounding electrode system must be installed at every building or structure where an electrical service, feeder, or branch circuit enters. This ensures a reliable path for fault current to return to the source, tripping the overcurrent protective device such as a circuit breaker, and minimizing the risk of electrical shock. Section 250.118(6) of the NEC specifies that a grounding electrode conductor, also known as a grounding wire, is needed to connect the grounding electrode system to the grounding terminal of the main service disconnecting means, as well as all other disconnecting means. This conductor provides a low impedance path for fault current to flow back to the source, facilitating the operation of overcurrent protection devices. Section 250.148(5) of the NEC requires a neutral conductor to be connected to the grounded conductor at the service entrance. This connection establishes the reference point for the electrical system and ensures proper operation of grounded circuits. Section 210.4 of the NEC mandates that a neutral conductor must be run with all ungrounded conductors. This ensures that the neutral conductor is always present to carry the return current from the loads connected to the ungrounded conductors. Therefore, the 4 wires that should be installed are firstly 2 ungrounded conductors, also known as hot wires. These wires carry the current from the main panel to the subpanel, powering the electrical devices in the garage. Secondly, 1 grounded conductor, the neutral wire. The neutral wire provides a return path for the current, completing the circuit. Thirdly, 1 grounding conductor, the ground wire. This wire provides a path for fault current to return to the source, protecting against electrical shock. In some cases, an additional grounding rod may be required to provide an adequate grounding electrode system. The NEC requires a minimum of 2 grounding electrodes for dwelling units, as specified in Section 250.56. In the context of a subpanel in a garage, an additional grounding rod may be necessary to ensure a low resistance path to the earth if the existing grounding electrode system is not sufficient. The purpose of the ground rod is to provide a direct connection to the earth, helping to dissipate fault currents and stabilize the voltage potential. To further elaborate on the necessity of a 4-wire system, consider the function of each wire. The 2 hot wires, typically carrying 120 volts each in a standard residential setup, provide the electrical potential difference that drives the current through the connected loads. The neutral wire serves as the return path for the current, completing the circuit and allowing the electrical devices to operate. The ground wire, on the other hand, is a safety conductor. It is connected to the metal enclosures of electrical equipment and appliances, as well as to the grounding electrode system. In the event of a fault, such as a short circuit between a hot wire and a metal enclosure, the ground wire provides a low impedance path for the fault current to flow back to the source. This high current flow triggers the overcurrent protective device, such as a circuit breaker, to trip and disconnect the circuit, preventing electrical shock and minimizing the risk of fire. The ground rod, driven into the earth, provides a connection to the earth ground. This connection helps to stabilize the voltage potential of the electrical system and provides a path for fault currents to dissipate into the earth. The NEC specifies minimum requirements for grounding electrode systems, including the size and type of grounding electrodes, as well as the methods for connecting them to the electrical system. The inspector's insistence on a 4-wire system and a ground rod is not arbitrary, but is rooted in the NEC requirements and sound electrical safety principles. By adhering to these guidelines, the risk of electrical shock, fire, and equipment damage is significantly reduced. It's important to understand the difference between the neutral wire and the ground wire. The neutral wire carries the normal return current from the loads, while the ground wire only carries current during a fault condition. The neutral wire is intentionally grounded at the service entrance, while the ground wire is connected to the grounding electrode system. In a 3-wire system, the neutral wire is sometimes used as both the neutral and the ground, which can create a potential safety hazard. If the neutral wire becomes disconnected, the metal enclosures of electrical equipment can become energized, posing a risk of electrical shock. In a four-wire system, the neutral and ground wires are kept separate, providing an additional layer of safety. The ground wire provides a dedicated path for fault current, ensuring that the overcurrent protective device will trip quickly in the event of a fault. The size of the conductors used for the subpanel feeder is also important. The NEC specifies minimum conductor sizes based on the ampacity of the circuit. The ampacity of a conductor is its current carrying capacity, and it depends on the conductor's size, insulation type, and installation conditions. It's important to select conductors that are appropriately sized for the load they will be carrying to prevent overheating and potential fire hazards. The overcurrent protective device, such as a circuit breaker, should also be sized appropriately for the conductors and the load. The purpose of the overcurrent protective device is to protect the conductors from overload and short-circuit conditions. The overcurrent protective device should trip before the conductors overheat and become damaged. The installation of the subpanel should be performed by a qualified electrician who is familiar with the NEC requirements and local electrical codes. A qualified electrician will ensure that the subpanel is installed safely and correctly, minimizing the risk of electrical hazards. The electrician will also be able to advise on the appropriate size and type of conductors, overcurrent protective devices, and grounding electrodes for the specific application. In conclusion, the inspector's requirement for a four-wire system and the ground rod for the residential garage subpanel is in accordance with the NEC requirements and is essential for electrical safety. By adhering to these guidelines, the risk of electrical shock, fire, and equipment damage is significantly reduced. Understanding the function of each wire and the importance of proper grounding is crucial for ensuring a safe and reliable electrical system. The use of a four-wire system ensures separation of the neutral and ground paths. The ground rod provides an additional layer of protection by connecting the grounding system to the earth. When installing a subpanel, firstly, always consult with a qualified electrician to ensure that the installation meets the NEC requirements and local electrical codes. Secondly, use appropriately sized conductors and overcurrent protective devices for the load. Thirdly, install a four-wire system with separate neutral and ground conductors. Fourthly, install a grounding electrode system, including a ground rod, to provide a connection to the earth. Fifthly, ensure that all metal enclosures of electrical equipment are properly grounded. Sixthly, test the grounding system to verify that it is functioning correctly. Seventhly, label all circuits and components clearly. Eighthly, keep the subpanel clean and free of obstructions. Ninthly, periodically inspect the subpanel for any signs of damage or deterioration. Tenthly, if you are not comfortable working with electricity, leave the installation to a qualified electrician. Remember that electricity can be dangerous, and it's always better to err on the side of caution. Properly installed and maintained electrical systems are essential for the safety and comfort of your home. Ignoring the NEC requirements can lead to serious consequences, including electrical shock, fire, and equipment damage. The inspector is there to ensure that the electrical installation meets the minimum safety standards and is in compliance with the NEC. By working with the inspector and following their recommendations, you can ensure that your electrical system is safe and reliable. Understanding the principles of electrical grounding is fundamental to ensuring safety in any electrical system. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protective devices to quickly trip and de-energize the circuits. Without proper grounding, fault currents can take unintended paths, potentially energizing metal enclosures and creating a shock hazard. The grounding electrode system, which includes the ground rod, provides a connection to the earth, helping to stabilize the voltage potential and dissipate fault currents. The NEC specifies requirements for the size and type of grounding electrodes, as well as the methods for connecting them to the electrical system. It's important to select grounding electrodes that are appropriate for the soil conditions and the size of the electrical system. The grounding electrode conductor, also known as the ground wire, connects the grounding electrode system to the grounding terminal in the electrical panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The grounding electrode conductor should be installed in a manner that protects it from physical damage. It should be securely fastened to the building structure and should not be run in areas where it is likely to be damaged. The connection between the grounding electrode conductor and the grounding electrode should be made using approved methods. The connection should be tight and corrosion resistant. The NEC specifies approved methods for connecting grounding electrode conductors to grounding electrodes. It's important to follow these methods to ensure a reliable and safe connection. In addition to the grounding electrode system, all metal enclosures of electrical equipment should be properly grounded. This includes the metal enclosures of electrical panels, junction boxes, and equipment. The metal enclosures should be grounded using a grounding conductor that is connected to the grounding terminal in the electrical panel. The size of the grounding conductor should be determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the circuit conductors. The grounding conductor should be installed in the same raceway as the circuit conductors. This ensures that the grounding conductor is protected from physical damage and that it provides a lower impedance path for fault current. The connection between the grounding conductor and the metal enclosure should be made using approved methods. The connection should be tight and corrosion resistant. The NEC specifies approved methods for connecting grounding conductors to metal enclosures. It's important to follow these methods to ensure a reliable and safe connection. Regular inspection and maintenance of the grounding system are essential for ensuring its continued effectiveness. The grounding system should be inspected periodically for any signs of damage or corrosion. Any damaged or corroded components should be replaced immediately. The connections between the grounding conductors and the grounding electrodes should be checked to ensure that they are tight and corrosion resistant. If any connections are loose or corroded, they should be tightened or replaced. The ground rod should be checked to ensure that it is still securely driven into the earth. If the ground rod is loose, it should be driven further into the earth. By following these guidelines, you can ensure that your electrical system is properly grounded and that you are protected from electrical shock.